right, this is a little review for your Chapter 3 test. We have one problem actually two problems from earlier in the unit, just to remind you of some of these concepts. So we have this function here. We want to identify the following, and this is just a reminder that you will want to use your calculator for this. And in the past, this would have been a calculator question as opposed to a non-calculator question on your assessments. So my suggestion would be let's try to factor this first. And specifically, the bottom we know is x plus 3, x minus 3, which will help us determine our domain, x such that x is not equal to plus or minus 3. Now, this top part is not going to factor. We don't have anything that multiplies to 5 and adds to negative 3, so that tells us that both of these are going to be vertical asymptotes. All right, our y-intercept again is just when x is 0, so I can go ahead, cancel, 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 and that'll give you a 0, negative 5/9. All right, now your end behavior asymptote. End behavior asymptote, remember, can be a horizontal asymptote or something different. And what you want to look at are the degree of your numerator versus the degree of your denominator. Since our degree is bigger on top, that means we do not have a horizontal asymptote and we will have to do long division. Okay. All right, and actually I have messed this up already because we do need to leave a placeholder for the 0x cubed. And for the 0x. Okay, all right, here we go. X squared times something is x to the 4th. It's going to be an x squared. X squared times x squared is x to the 4th. X squared times negative 9 is negative 9x squared. Cancel, that's still gone. Negative 3 plus 9 is 6x squared. X squared times something is 6x squared, that's a 6. Multiply, never changed colors, but that's okay. 6 times negative 9 is negative 54. And bring down our 0x. It's not going to matter anyways. Cancel. Bring down our 5. And we just have 5 minus 54, or excuse me, 5 minus negative 54, which is a 59. But either way, it doesn't matter. X squared cannot go into 59. And I'm just actually going to move my plus 6. Should be here. So that is my end behavior asymptote, y equals x squared plus 6. Now, intermediate and end behavior, we will need to actually graph this whole function in order to see that. So let's type this in. And I'll use my alpha y equals enter. Okay, so this is something to be really careful of, all right, because again, you know you have vertical asymptotes at positive 3 and negative 3, and on vertical asymptotes you always have something both to the left and to the right of it. Okay, you also should notice that because your vertical asymptotes have degrees of 1, that your end behavior, or excuse me, your intermediate behavior is going to be going opposite directions. So as we approach the vertical asymptote for these two guys, it's going down, so it must be going up on the other side, which means your window needs to go up. So let's just try 50 and see how that looks. Just a random guess. Oh, and it looked just fine. Okay, so if you want to kind of balance this, you can make your y-min negative 50 if you'd like. There we go. All right, so now let's go ahead and set up our intermediate behavior. We have as x approaches, let's do negative 3 first from the right. f of x approaches, and as x approaches -3 from the left, f of x approaches. It doesn't matter which one you do first. So -3 is here. As we approach from the right, we are going down. So this is approaching -infinity. And we should already know it's going opposite directions because of our degree again, but as we approach -3 from the left, it is going up, so that's +infinity. All right, and then our other ones are as x approaches +3 from the right and +3 from the left. Okay. So +3 right here. As I'm approaching from the right, what's happening? It's going up. So approaches +infinity. And as I'm approaching 3 from the left, so I'm coming from this direction, it is going down -infinity. Now, if you'd like, we can also type in our behavior asymptotes that we found, x² + 6. And you can see it's just going to kind of cradle these two little guys up here. It's showing our end behavior in both directions as x approaches +infinity and as x approaches -infinity. You can see these guys are going up. So what you want to make sure you do here, and I have mentioned this before, as x approaches +infinity, f of x approaches. Your only options are a number, which is what happens when we have a horizontal asymptote, +infinity or -infinity. You don't want to say it approaches x² + 6. Do not do that. You need to say what it's actually doing. It's going up. And it's going up on both directions. So +infinity for both of these guys. Okay? And it's going up for both because the asymptote is a parabola. And we know parabola, its end behavior is the same on either side. Okay? All right, little reminder of that stuff. Next, given a circular cylinder with a volume of 600 inches cubed, find the length of the radius needed to minimize the material used, meaning surface area. Be able to write your equation without a calculator. Know these formulas for your test. Okay, so again, in the past, you would have non-calculator and calculator portions. This is a problem you should be able to do a non-calculator or do non-calculator, but again, I cannot, I can't really police that. So, you should be able to do in this class anything you can do without a calculator. You should do that. So some formulas you need to know. Again, volume is just area of the base times height, and surface area is perimeter of the base times height plus the area of the two bases. And I'm just going to draw a beautiful little picture here. Very nice. And we're looking for the radius to minimize material. All right, so let's start off by writing our surface area formula because that's what we're actually trying to find. And here, that's my R. And that's my height. So perimeter of the base, that's really just circumference, which is going to be 2 pi r times h plus 2 area of the base. Well, again, the area is a circle, so the area of our base is pi r squared. Our issue here, of course, is that we have an h as well as r's, so we're going to need to eliminate that h. And we're going to do that by using our volume formula, because they are told, or you are told, that your volume is 600. Again, area of the base is just pi r squared, and then that h. So we're going to go ahead and solve for h by dividing. And then this guy can just get plugged in right here. And you can simplify as much or as little as you'd like, because again, this is just going to get plugged into your calculator. But I mean, it's easier to type it into your calculator if you simplify it, I think. So 2 times 600, that's going to be 1200. The pi's are actually going to cancel, which is nice. And then one of the r's is going to cancel. So you'll just have 1200 over r plus 2 pi r squared. Okay, so there's your surface area formula. And now again, we're minimizing surface area. So we will have to type that in. 1200 over r, which I'm just going to put x, plus 2 pi x squared. And we'll do zoom 6. Okay, over here, this would be the radius is negative, which obviously I can't do anything with that. I don't see anything else, so I'm going to check my table. And you can see when the radius is 10, we're already up at 748. So that is pretty big. So let's change our y max first. I'm just going to go with like a 2000. And actually you can see the minimum right there. So we'll go ahead and find it. There it is. Left bound. Right bound. Guess. Okay, so I'm getting a minimum of 4.571. Just draw that lovely picture. 4.571, comma, 393.806. Okay, and again, just to make sure we understand what these values mean, that 4.571, that's your x coordinate, but it's representing your radius. And that 393, that's your y coordinate, but it's representing your surface area. Right? And again, they want to know the length of the radius. And does it actually ask for the surface area? No, it doesn't. So I'll just say radius is 4.571 inches. And that would be my final answer. All right, please reach out if you have any questions. Have a great day.